On to Friday the 13th, January 2023. This is Pomodoro Joe, and today we'll be doing LeetCode problem 2246, longest path with different adjacent characters. This is a hard problem. You are given a tree, i.e. a connected, undirected graph that has no cycles, rooted at node 0, consisting of n nodes numbered from 0 to n minus 1. The tree is represented by a zero-indexed array parent of a size n, where the parent at I is the parent node of node I. Since node 0 is the root, parent at 0 is going to be equal to -1. You are also given a string s of length n, where s at I is the character assigned to node I. Return the length of the longest path in the tree such that no pair of adjacent nodes in the path have the same character assigned to them. Oh, this is tricky. So here's an example. They've got a tree with some nodes, but 0 and 2 both have A's assigned to them. So the longest path has to go from A to B to C. So 0, 1, 2, or 0, 1, 3. And that is our longest path. All right, so without further ado, we will set 25 minutes on our Pomodoro timer and jump right in. So with this one, the first thing that we'll want to do is convert this parent array into something a little bit more useful to us, like a list of the nodes and their connected nodes. So we'll create a new node list. Maybe we'll make it a dictionary. It could be a list, it could be a dictionary. We'll make it a dictionary. So we'll have nodes, and we'll actually make this a default dictionary with set as the type. So essentially, the key will be the node, and the value will be the set of all the connected nodes to that node. And so we'll say for, let's see, we'll want index and parent in enumerate our parent array. So this gives us the node, which is I, and its parent, which is P. So we'll call this nodes plural. So nodes at P will add node I. So P is the parent, and that's the key. And all the nodes that it's connected to are going to be the value in that dictionary. All right, so now we have these broken out into something a little bit more useful. We can get each node and all the connected nodes to that node. All right, next thing we'll want is we'll see some result here for our answer, and we will return the result at the end. Okay, so this gives us our basic pieces of code that we'll need. The next step is to actually traverse these nodes and try to find the longest path. So for that, we'll have a recursive algorithm. So I'm just going to call this longest path recurse. Okay, and it will take a node, and it will return an integer. Sorry, I've been doing other languages here. Okay, so it will return an integer that gives us the longest path from this node. So how do we figure out what's the longest path from this node? Well, either this node is in a path, meaning it's not the end of the path, but it is in a path, or it is the end of a path, or there are no paths and this node just has maximum length of 1. So we'll call this longest path. Or I'll call this recurse result. And we'll set it to equal 1 to start with, and we'll return our recurse result. Okay, so what else do we know about this? Well, if we are trying to figure out, let's see, here's another example down here. Yeah, so it's not necessarily a binary tree. So if we're trying to figure out the longest path, in this case, the longest path goes, it looks like, from 2 to 0 to 3. So 2 up to 0 and back down to 3. So Node 0 is in the middle of the path. If you're in the middle of a path, you kind of want to find all the paths that can possibly branch off of this node and then find the two longest paths, because if this node is in the middle, you can come from one of the longest paths and then go out to the next longest path. So we want two of the longest paths from this node. Oh man, so how are we going to do that? We're going to have longest path A, and that's going to be 0 to start with, and longest path B, that's also equal to 0 to start with. All right, and then we'll want to go through and find these longest paths. All right, so how do we find the longest paths? We're going to have to go through each one of the connected nodes to see, do they have long paths? Let's find out. So for connected node, in all the connected nodes, which is going to be nodes at this node, that's the set of all our connected nodes. So for connected node, in our potential set of connected nodes, that's the first thing we'll do is we'll just create a variable that's called path. So this is the longest path. Maybe I'll call this longest path. So this longest path for node is going to equal, well, this is going to be our recursive call here. What is the longest path for this node? Okay. Now, if this path is the longest path, so we just looked at all the child nodes and tried to find the longest path, it doesn't necessarily mean it goes through this node. It just means that that is the longest path from the child node to all of its children. So that's potentially one of the longest paths. Let's say, for example, in this example here, let's say 5 actually had a long path going down off the screen. That actually could potentially be a longer path than a path that leads up to node 2. Actually, that's a bad example. In this case, let's say it's node 2. Let's say 2 goes to 5 and further down. If you're looking at node 0, it doesn't necessarily mean that the path goes through node 0, because you can't actually get from node 2 to node 0. But there could be a longest path from node 2 down through 5. So this longest path for the node is potentially our longest path. So at this point, we can say our recurse result is going to be the max of our recurse result, our current result, or this longest path for the node. All right. Now, what about paths that do include our current node? Well, the first thing is we have to look for whether or not these paths have characters that are matching, because if they are, then we cannot include this node as part of the longest path. So if, what's it called up here? S. So if S at the connected node is the same as S at this current node, well, then we can't actually go down that path, so we'll just continue. Otherwise, we could go down this path. We need to check to see if this longest path is greater than our two longest paths that we've already got up here. So if the longest path for this node is greater than our longest path A, then, well, we're going to set longest path B. Let's see, longest path B equal to longest path A, and then we'll set longest path A equal to longest path for node. Basically, we're just trickling this down. Otherwise, if this longest path for node is greater than longest path B, so it's smaller than A but greater than B, then we'll just replace B with this longest path. I'll fix that up in a second. All right. So this just keeps track of our two longest paths that branch off of this node and that include this node. Okay, so once we've gone through all of this, we've found the longest possible paths. Now we can say our result here, our recurse result. Actually, in fact, we can say our whole program result is either the max of the result of our current result or our recurse result. But one thing we need to do is update our recurse result. So our recurse result here, that's going to be the maximum of the longest path, or actually we've already done this longest path, so it's going to be the maximum of our current recurse result, or the longest path A. So we came from path A and we go to path B and we add one for this node that's in the middle. So we can have a recurse result that goes basically, if we were looking at, say, node 1 here, we're going to look at path A, which is the longest path down. This way, this is maybe a bad example. Let's say this wasn't B, this was like a D. Then we'll look at that is the second longest path, and we're in the middle, so we have two longest paths. Okay, not explaining that very well, but try to work this out in your mind, because it does help to try to picture what this is telling us. And then when we're finally at the end here, we can return our recurse result. Okay, and at the very end of our whole program, we will return our result, which should be the maximum that we've found so far. And before we can run this for our first test, we actually need to call our recursive algorithm once with the root node. Okay, I think this handles it. Let's run this, see how many typos I made. All right, where are we failing here? Local variable result, reference before this. So it's saying this is a local variable. So I have to say non-local result. There we go. That's the problem. Oh, and it works. Okay, let's give this a shot and see how well we do. We are out of time, but let's just see how this goes. Wrong answer. We only passed 41. Okay, so clearly I have some mistakes in here. All right, I think I know what it is. So I think I don't need to return the recurse result here, because this will be the whole path. I really want to return the longest path plus this node. I think that's my mistake. I should not have included the entire path. Try this one more time. There we go. So that was my mistake. I was including the entire path and not just the longest path from that node down. All right, there you go. I think we're out of time. We only beat 69% of other entrants in terms of runtime and only 11% in terms of our memory. So there are definitely improvements you can make to this solution. Try it on your own. It's a fun one. It's hard. I will tell you, it is not an easy problem. But give it a shot. Try it out. Hope you learned something. Hope you had some fun. Go out and write better code.